what's up? Welcome back to the channel. Thanks for joining us again. So last couple videos I haven't been working on my own stuff, so I decided to make a video for my subscribers, let them know exactly what's going on with the stroker build. Last couple videos been up at Pete's place hanging out on the dyno, and we're gonna go back up there soon. He's got a couple other engines he wants to throw up on there, including a 5.7 Gen 3 Hemi, which would be pretty cool, so we'll be back up there soon. This video though, I thought I'd let my subscribers know exactly what's going on with the build. I got a couple parts in, I'll show you guys what I got here, and I got some stuff ordered. Now you guys know what's going on with ordering stuff and part shortages. We're dealing with that a little bit, but all the main components we either have or are on the way. Plus I have the block up at a machine shop. It's been checked over, so we're gonna get into all that detail information for you guys right now. We're gonna be talking about the crankshaft, connecting rods, pistons, and the block itself, and maybe it'll help you piece together a stroker kit or even just enlighten you a little bit further onto how you would purchase pistons, connecting rods, or a crankshaft, or if you want to send your block out to get it machined, zero decked, even line honed, all that stuff we're going to talk about. Okay, so I guess we'll dive right in, and the main problem we had with the last motor was the oiling system, so I purchased a new pan, pickup, and pump. I'll show you guys what I got and kind of talk a little bit about that. Okay, one of the first things I wanted to do right away was address the oiling problem that we had. When we were accelerating throughout the run, we would lose pressure, and I simply believe that the oiling system was not keeping up. Our stock style Milodon pan only held 4 quarts. I stepped it up to the bigger one. This holds 7 quarts, 3 additional quarts. You can see the nice kick out on it, and it has some extra baffling inside, so that way when you accelerate, when the oil goes to the back, the pickup can still grab it. That baffle should hold it in there a lot better than that stock style Milodon we had. It had some baffling in it, but again, with only 4 quarts capacity, this 7 quart is much better. 3 additional quarts. And another nice feature about this pan, it's only ½ an inch deeper than a stock style one. So you get 3 more quarts at only sacrificing a ½ inch of ground clearance. That's a win in my books. I'll show you guys that part number there if you're interested. And then with that guy, you pair it with this Milodon pickup. Now this is for an HD pump. They are a little different if you have a standard pump or not. This is for HD, bigger tube, bigger pickup, nice unit. And there's our new Melling high volume pump. That's why you gotta have a special unit for that, because they're a little bit taller, so that guy's a little bit shorter than a stock one. And then that high volume pump, they do recommend that you get a hardened drive shaft for it. So I picked one of those up, Milodon too. Came with the bushing as well, so we'll get that pressed into the block. But that's gonna be the new bottom end oiling system. Okay, now that we checked that out, let's get on to the good stuff. We'll check out that crankshaft. Okay, so what we got here is a Mopar Performance 4-inch stroker crankshaft for a Mopar 360. It is a steel crankshaft, it is a cast steel crankshaft, and it is set up for internal bounce. It has a 4-inch stroke, so a stock 360 has a 3.58 stroke. This is a 4-inch stroke, therefore increasing the piston's travel, increasing the size of the engine. That's how you get a stroker motor, increasing the size of the stroke. Okay, so how I selected this crankshaft is, first of all, it offers tremendous value for its strength. It's a lot cheaper than a forged unit, and it's readily available. It was recommended to me by Pete. He's run a half dozen in these in 408 builds and never had a problem. My 2 buddies at the track also run this crankshaft, and they've never had a problem. It is cast steel, it's not cast iron. Our original stock crankshaft was cast iron, and crankshaft hierarchy goes cast iron, all of our stock 360s cast steel, like this unit here, forged steel, and then billet. If you're looking at a billet crankshaft, you shouldn't be watching this channel. So this guy offers tremendous strength for its value, and we can strengthen it further by using an internal bounce instead of having the counterweights bouncing at opposing ends of the crankshaft. The crankshaft is bounced and the rotating assembly is bounced internally, spreading the load across it. And we're also going to be adding a main cap girdle to our main cap so they cannot flex and walk around, stiffening the whole bottom end. So this cast steel unit, although it's not a cast forged unit, is going to be great for a 600 horsepower build. After I bought it, I posted a picture on I think Instagram and YouTube as well. A couple guys hit me up right away and they said, I've been running that crankshaft on a W2 headed small block for years, never had a problem, so I'm quite confident in the strength of the bottom end and pretty happy with the value of this crankshaft. So my original idea for this build was to put a forged crankshaft in it, and then down the road upgrade cylinder heads, camshaft, and try to make like 700 horsepower, which a lot of guys do on stock blocks. But talking to people, more and more people were telling me that 650 is kind of the limitation of the block. So that crankshaft there is going to work great for our 600 horsepower program. And now I can start searching for an R block or perhaps a Ritter block after we complete this engine. So it just never ends. You're building one motor and you're still thinking about the next. But let's take a look at these connecting rods because they pair really nicely with that crankshaft.
Okay, so we got ourselves some Eagle H-beam rods. There's a part number for you guys. Pretty sure I got the last set on Summit though, like I was talking about earlier, those part shortages. So they are 6, 1, 2, 3 in length. They are an H-beam rod, like you can see there. They all come sealed like this. They don't want you to touch them until they actually go into the motor. When you're buying connecting rods, you can either go with an I-beam or an H-beam. H-beam is far superior. And then I noticed too, for Eagle anyway, they do come with ARP studs. And then it's actually the stud that changes the strength after you get to the H-beam pattern. These ones here are rated for 750 horsepower, 7,500 RPM, so great for our application. The next step up was like 1,100 horsepower, so that might be the next set of rods. But these Eagle H-beams looking pretty nice.
Okay, so I sent my block away to a machine shop a few weeks ago, and I've been talking with them quite a bit because to order pistons, we need to check the block. So first thing they did is check it for cracks. They sonic checked it to see how much meat was in the cylinders because we did want to overbore it again. It was already bored over once. We wanted to go further, so they checked that out for us. They also checked out the deck height. Now, deck height is important when you're looking at the compression height of a piston you want to select. So my engine was zero decked before, so when I selected a piston with a slightly shorter compression height to make sure we still had deck room so we could redeck it to zero and get it absolutely perfect. And then when we were checking our cylinder bores with the sonic checker, they determined that there was lots of meat in there, so we decided to go with a 60 over bore, which I'm pretty stoked about because of instead of having a 408 at a 4030 bore and a 4-inch stroke, we're going to go to a 4060 bore with a 4-inch stroke, and we're going to end up with a 414 cubic inch small block, which is pretty awesome. And we have selected a piston that fits our needs. We're going with a set of Icon pistons. They are a slightly dished piston with a volume of plus 13 cc. So once we zero deck the block, we take that plus 13 cc. We also will have a 40 thou compressed gasket and a 60 chamber on our heads. We're going to end up with a really nice compression ratio of 11.4 to 1. And because I run 94 at the pump here, that's still pump gas for me. I might put a little something in it on race days, but that's the basic build of the block where we're at right now. So those guys actually ordered the pistons, that's why I don't have them right now. So as soon as they get here, and then once we get the main girdle in, I'll send all the components up there. They'll bolt the main girdle to the main caps, line hone everything, bore it out, and then they can start the build on the short block itself.
I'll show you guys this real quick too. I have started looking at porting out that Super Victor intake. That's going to be a different video though, but just to let you guys know, I am plugging away and look at how much room we got to work with on that thing. So that's a future video though. Just thought I'd show you guys.
Okay, so that brings you guys up to date where we're at on the build. I do want to thank you guys for coming along on this journey. I do appreciate all the questions, everybody asking what's going on with my stuff. Not too sure what the next video is going to be. Maybe porting that intake, maybe some engine-based stuff. Might be back up at Pete's house hanging out on the dyno, so do stay tuned for that. Thanks again for watching, guys, and we'll see you guys real soon.